All right, here's some factoring help for Factor Practice 924. For the first problem, I can see that this is a trinomial. So what I'm going to do before I decide if it's just a regular one or if it needs slide divide is I'm going to try to see if there's a GCF. So between 2 and 14 and 60, I can see that all of those are even numbers. And so I'm going to take a 2 out. And once I've done that, I can see that the n squared is all by itself. There's no number with it, which means that it is just a regular factor or a regular trinomial. It does not need to use the slide divide method. So negative 30, positive 7, we are choosing two numbers that multiply to negative 30 that add to positive 7. And I'll let you guys go ahead and finish that one. When we look at number 2, I can see that there are only two terms there. So I'm not thinking trinomials, I'm not thinking slide divide. That means my options are GCF, difference of squares, or sum or difference of cubes. And GCF is always what I try when I get started. So between 56 and 16, I want to see if I can divide a number out of those, a GCF. And both of these are actually divisible by 8. So I'm going to go ahead and divide 8 out of both of those numbers. 56 divided by 8 is 7. So I have 7x squared. 16 divided by 8 is 2. And at this point, I'm going to kind of ignore the 8, and I'm just going to think about what's left over and think if I can keep factoring it. It's still two terms. I know I'm not going to use GCF now because I just did, so I'm done with that. Now I'm going to think difference of squares or sum or difference of cubes. There's nothing cubed in here, so I'm not thinking that. With difference of squares, I can see that x squared is a square. I can see this is a minus. But when I think about my perfect squares, 7 and 2 are not on my list of perfect squares. So there's nothing else I can do to factor it. That is not difference of squares. That means all I had to do was GCF, and I'm completely done. All right, number 3. So here we have a binomial. We have to think GCF, difference of squares, sum or difference of cubes. And so for this one, I can see there's a GCF between these two terms. There's an x that or not an x, there's a 2 that I can take out. And that leaves me with x to the third plus 8. And now when I look there, I can see that I have something cubed, and I have an 8, which is a perfect cube itself. And so that means we're going to do the sum of cubes formula. So something cubed plus something cubed. And the first thing we have is x cubed. That one's kind of easy. 8 is the same thing as 2 cubed. And so now I'm just going to walk myself through the pattern with sum or difference of cubes. So my first parenthesis, I start off with the first term, the same sign, and the second term. So I'm going to have x plus 2. So same sign, x plus 2. And then when I start my next parenthesis, I'm going to have the first term multiplied by itself. So x multiplied by x. And then I have to do the opposite sign. So if the same sign was a plus, the opposite sign is a minus. And I do the first term multiplied by the second term. So x multiplied by 2. And then the next sign that I do is always positive. So if you guys remember that acronym SOAP, same sign, opposite sign, always positive. And then we do the second term multiplied by itself. So if you're struggling with these problems, the colors are a good thing to get out because you can see the pattern really well. So first term, same sign, second term. First term multiplied by itself, opposite sign. First term multiplied by second term, always positive. Second term multiplied by itself. And then I can go ahead and clean up my answer. And of course, I'm going to remember that GCF in the front. And I'm finished. All right, for number 4, again, we have a binomial. It has 2 terms. I have to think about if it's a GCF problem, is it a difference of squares problem, is it a sum or difference of cubes problem. And here I can see 16 and 49, one's even, one's odd. I recognize both of those numbers actually as being perfect squares, 16 here and 49 there. That's a squared, p squared, and there's a minus, and so this seems like a difference of squares problem. So I'm going to go ahead and write 2 sets of parentheses, one with a plus, one with a minus. The square root of 16 is 4, so I'm going to put a 4 in each spot. The square root of p squared is p. The square root of 49 is 7. And that's it. I'm done. All right, let's look at number 5. Anytime something looks like this, we got numbers, we got 2 different letters, that's basically just a GCF problem typically. So I have a leading coefficient or a leading term that's negative. That means for sure when I do my GCF, I'm taking a negative out. The 2 numbers are even, so they're definitely divisible by 2, but I want to see if maybe I could divide something out bigger. So they're not divisible by 3. They are both divisible by 4. Not 5, not 6. That one's divisible by 7, but that one is not. That one is divisible by 8, but that one is not. So it looks like 4 is probably our best option. So I'm going to take out a negative 4. This one has an x, but this one doesn't, so I can't take it out. This one has a y squared, that one has a y to the 3rd. So I always go with the smaller exponent. So y squared is what I'm going to take out. All right, negative 28 divided by negative 4 is 7. I took the y squared out, but I'm going to leave the x squared behind. Negative 8 divided by negative 4 is positive 2. I had a y to the 3rd. I took out y squared, so I took out 2 of them. That means that there's 1 left over. And this doesn't really look like anything. I don't see any perfect squares. I don't see any perfect cubes. That one's just done. All right, for number 6, we have a trinomial again. And so I have to think about whether or not there's a GCF. And when I look at this problem, 7 is a prime number. 7 doesn't divide into 45. 7 doesn't divide into 50. So that means that this is just, it's going to stay that way. There's no GCF. So now what I want to think about is if this is a regular trinomial or if it's a slide divide problem. The 7 in the front tells me that it's a slide divide problem. I'm going to slide the 7 over to the 50. So I'm going to be looking for 2 numbers that multiply to 350. That's what I get when I do 7 times 50. So 2 numbers that multiply to 350 but add to negative 45. I'll go ahead and let you guys finish that one. Let's jump down to number 7. Again, we have a trinomial. Again, we're going to look for a GCF before we get started. So between all these numbers, I recognize that they're all divisible by 3. So I'm going to go ahead and take that 3 out. I get r squared. 27 divided by 3 is 9. 60 divided by 3 is 20. So now I'm going to ignore that 3 and I'm going to think about what I have left behind. This is a trinomial. The r squared is all by itself. So that means that this is a regular trinomial. It is not a slide divide problem. So I'm looking for 2 numbers that multiply to 20 but add to 9. 2 numbers that multiply to 20 but add to 9. I'll go ahead and let you guys finish that one. And then for number 8, last but not least, again, we have a trinomial. Again, I'm going to look for a GCF. Between the numbers, I can see that 10 goes into 20, but 10 doesn't go into 17. In fact, 17 is a prime number, so nothing really goes into 17 except for 1. So there's no number that I can take out, But when I look at the a's, I can see that the exponents are a little bit off from what I would expect. And then I notice there's actually an a inside each term. So that means that a is the GCF that I can go ahead and take out. All right, so 10a to the third, I'm going to take an a out. That leaves me with 10a squared. I'll take an a out there. That leaves me with minus 17a. Take an a out there. That leaves me with negative 20. And if I look at this problem now, I can see that I do have a trinomial still, that the a squared has a 10 with it, which means that this is a slide divide problem. So I'm going to do 10 multiplied by negative 20, and I get negative 200. So I'm taking two numbers that multiply to negative 200 but add to negative 17. And I'll go ahead and let you guys finish it from there.